that?
Yes.
Yeah, okay. So the this first question was 31 billion, and there are 292 school districts, and it asked you, how much would each district get, basically, if we split it up equally. I think it's something like that. Let me get back to the page. Reason why I like these questions is because they kind of highlight one of the central problems of quantitative reasoning, which is that you are going to get a bunch of words and there's going to be some numbers in there, and the expectation is that you're going to understand what to do based on the words. And that takes practice. So if you looked at some of these questions and it didn't immediately occur to you what to do, part of what I want to help teach you is how do you recognize and identify the type of problem that you're dealing with. And this is a bigger issue of learning within the context of this class. I mean, in the real world, there are no sections and units and tests. It's just there may be a situation and there's a problem, and so then you have to figure out what to do and how you're going to solve that problem. But in the confines of a class, there's a structure that says, okay, we're working on section 2, we're working on section 3, and sometimes that can be helpful in guiding you in terms of what to do. These questions are more general application questions that involve big numbers. That's why it's in this section. And I like them because there's no kind of set, like if you thought maybe all of these were going to be ratio questions, I hope you realized that that's not accurate when you looked at one of your answers. Now, the math here is not complicated. In general, you can look at all of these. You're given two numbers, and at the level of math that we're doing, all we're going to be up to really is multiplying, dividing, adding, subtracting something. I mean, there's some situations where maybe we subtract and then we divide or something like that, but it's not ever going to be a crazy 10-step process. The math isn't super complicated. It doesn't make the problem easy because of the two layers, that cheeseburger of quantitative reasoning. We got to interpret what to do the math, and then we have to reinterpret and contextualize the answer. Okay. So $31 billion budget. Yeah, go for it. Question? Nope. Okay.
Oh, no, I'm sorry. That was me.
Oh, all right. So first of all, recognizing that the 31 billion, you have to write it out. Like, it's not okay to ignore the billion. And the mathematics that's happening is division. And where that comes from is the word disperse. So they're basically trying to split up the money. Now, that's not actually how money gets split up between school districts. It's more complicated than that. And maybe some of that could be equity issues in terms of fairness and who gets the money. But I mean, most basically, not every school district has the same number of students, so it doesn't make any sense to split it up equally. So that's not actually totally accurate, but it's a kind of a starting point. We could take the 31 billion and we can divide it by 292 districts, and we can kind of look at what a district might receive from the state. When you do the division, you get a big number, right, with lots of decimals. And again, I want to empower you to round here and think about rounding. If you're going to talk about the answer, probably you would round to the millions. Like, we would not keep it just at the cents. I mean, we could write out this whole number in dollar notation. Oh, wait a minute. There's a button I can just click to do that. Boom. Right? That's what the number would look like in full digit, notation. And there's nothing wrong with that number, but if we're going to talk about it, it'd be a lot easier to just say 106 million. So something like each district would receive 106 million from the state. Something like that would be a way to contextualize. If the question required you to write an answer, that would be a nice way to communicate what you found. Any questions about that first question?
Now that's going to show me what? Because I divided it and I got the 106, but this is showing me what? The school district or the,
How much money each school district will receive.
oh, okay.
Right. And again, I try to bring the real world applications of this in and talk about how it really works in the world, because I don't want to, I want to make connections to what's really happening. I don't want you to get too lost in me talking about it if you know some of that consideration is getting in the way of you learning, then just kind of tune me out when I'm talking about this sort of thing. But I just want to acknowledge that that's not actually how a state would split up their budget. They don't just divvy up the money equally. And from a social justice perspective, this is a problem when you get down to individual schools, because individual schools are funded through property tax, principally local taxes. And so places where there's higher poverty don't get as much funding. So in a way, it would be better if we just said, hey, here's a school, it's a high school, you're going to need this much money, and every single high school in the state got the same amount of money, and you do with it what you're going to do. But that's really not the way it works. So there's a lot of complexity in how funding happens, and some of it is actually reinforcing systemic injustice and systemic racism. Okay, the second question I also like is, again, a very topical issue about incarceration, and the criminal justice problems and reforms are, connected to this. It doesn't have anything about criminal justice problems in this question, but it does kind of hint at it, because if we take 2.2 million Americans and each one of those people costs $25,000 to incarcerate, that's going to lead us to a pretty big number. Now, what we end up doing is multiplying. And if you struggled to kind of come up with multiplication as the way you were going to solve that problem, I want to talk a little bit about that. And again, it'd be nice if I could walk around and look at people and while they're doing their work, because typically people will attack this problem by, say, dividing. And when they divide, they look at this answer. And the reason they divide is because we've been talking about ratios. And so they're like, well, let me just try to divide this number and see what I get. And that's a perfectly rational thing to do. It's 88, right? But as you begin to recontextualize that answer, and you say to yourself, did I answer the question, how much is the US spending on incarcerations a year? Is my answer $88? Does it make sense for the US to be spending $88 given the other facts in this question?
Nope.
I hope you would say no.
No.
Because we're spending $25,000 a year per person, right? So $88 makes no sense. So to me, one of the ways that you check yourself is through the bottom layer, right? It's not just an extra step to punish you to say, we got to make this problem harder. It's like, that's real. If you reinterpret what the math means, that's your opportunity to say, man, that doesn't really make sense, or yeah, that does make sense, right? So division is not the right way to go about doing this problem. We would multiply. And one of the ways you can arrive at the fact that you need to multiply is to think about a simpler, similar problem. So this is a general problem-solving strategy, which basically, let me get back to this tab here. So one of the reasons that I think it's important to talk about simpler, similar, and general problem-solving strategies is because this class is about making you feel more competent in mathematics. And like I said, in the real world, if you run into a math problem, it's not in the context of a book where there's a chapter with examples that you can look at and say, well, it's probably like this example. You have to do the work yourself to figure out what is the math required for this particular situation. And part of that you get by doing problems that are relevant, so that when they come up, like you have 20% off at your department store, and you want to know how much money is that going to actually mean you get to save, like you've done enough problems like that that you can kind of remember how to do it. But one of the strategies that is really important that you're already using in your life is what I call simpler similar. And it's where you basically take a complicated problem and you either make it simpler or you make it similar, or you do both at the same time in order to get access to a way to solve it. So the example here is from further down on the page with the Lucas Oil Stadium. You may not look at that question and say to yourself, oh, I know what to do with those two numbers. But I think if you look at the second problem, which is a similar problem, you would have more of an idea about A, what the answer is, and B, what would you do with the number 40 and 5 in order to answer the question? So have a think about that for a second. What would you do?
You would times it.
40 times 5? 40 times 5 equals 200. Do I need 200 cars to take people to the party?
No, you divide.
40 divided by 5, 8 cars. Yes, this second one is correct. I would need 8 cars if every car holds 5 people. Now, multiplication does not mean that you're wrong, because there is multiplication there. It's 8 times 5, right? It's basically what times 5 equals 40. That's the question I'm asking. So if you're conceptualizing it like that, that's correct. It's just, that's not what you do between the 40 and the 5. So the point of solving the simpler similar question is that you can look at this one, I hope, and see what you would need to do between this number and this number in order to solve the problem. So just to go back to our particular problem, we were talking about 2.2 million people who are incarcerated. We're talking about $25,000 each. And so a simpler problem would be, what if I only had 2 people? What if I had 10 people, right? And so I hope that by making the first number smaller, it helps you kind of think like, oh, okay, well, if 2 people both cost $25,000, then I'm talking about $50,000. And that leads you to thinking about the fact that it's multiplication. So again, simpler, similar, it's just a general problem solving strategy that you can use any context. Doesn't have to be a math class. You're already probably using it when you solve problems in your life. So when I do 2.2 million times 25,000, I end up with this number. And this number is about $55 billion, which I hope seems like a very large number, because it is, right? And, you know, again, from just the meaning and the context of the problem, there's a lot of arguments that can be made about why are we spending so much money as a country to lock people up when we could be spending that money differently, like in investing in education, investing in resources, investing in mental health resources, investing in drug rehab. So it's a question of priority and policy, which has led us to lock up lots and lots of people, especially in the last 20, 30 years. It's an interesting thing to kind of learn more about if you're interested in criminal justice reform. Okay, any questions about those problems?
Yeah, so the number 2, so I mean, isn't there more to do than
Nope.
just the 55?
Nope, that's it. $55 billion. If once you multiply the 2.2 million and the 25,000, that's, you know, a rough approximation. It's not an exact number, because the 25,000 is an average. Some people aren't locked up for a whole year, but yeah, that's approximately the answer.
Okay, because it got me confused, because then it says spending on incarceration yearly. So I was thinking about the 12 months in a year.
Oh, okay, gotcha. Right. Yeah, but look at this detail. It says 25,000 for a year. And so that's why this word yearly is here,
Okay.
right? It didn't tell us how much it cost per month. It told us how much it cost per year.
Okay.
Yeah, but good attention to detail there, because that could become an issue, and later when we get into conversions, that will become something that we need to pay attention to.
So
Okay, and
Professor,
then, yeah.
I'm sorry, go on.
So the last question, again, I think has some relationship to where we are right now in the middle of this pandemic, and thinking about germs and thinking about sneezing and 6 feet of distance. And it's kind of a mind-blowingly large number to think about how many germs can be on a single droplet and how many droplets are in a sneeze. And again, I think a similar approach here can be helpful, because if you had 5 germs on 6 droplets, how many germs is that total? And in thinking about that, I hope can help you clarify what you're supposed to do in the problem.